सो 7 इनडिटर्मिनेट फॉर्म्स में से हमने पहले ही 4 इनडिटर्मिनेट फॉर्म्स डिस्कस की हुई है और अगर आपने वो वीडियोस मिस की है तो आप ऊपर आ रहे आई टैब पे क्लिक करके वो वीडियोस भी देख सकते हो एंड प्लीज सब्सक्राइब द चैनल टू रिमेन अपडेटेड विद न्यू वीडियोस। नाउ आज की वीडियो में हम इनडिटर्मिनेट फॉर्म्स ऑफ द टाइप इन्फिनिटी टू द पावर 0, 1 रेज पावर इन्फिनिटी एंड 0 रेज पावर 0 देखने जा रहे हैं। And these indeterminate forms are also called power indeterminate forms. Obviously, the forms are obtained due to the powers or indices. Now, किस टाइप की limiting form को हम power indeterminate form कहते हैं? If we are computing the limiting value of the function limit x approaches to fx to the power gx such that number first for x approaches to a when fx approaches to infinity and g of x tends to 0, then we say this limiting form is of the type infinity to the power 0 because fx infinity को जा रहा है and gx 0 को. That means this indeterminate form will be called infinity to the power 0. And number second, when x approaches to a and for x approaching to a, if fx approaches to 1 and gx approaches to infinity, fx 1 को जा रहा है and gx infinity को, that means this indeterminate form will be of the type 1 raised power infinity. And number third, if fx approaches to 0 and gx also approaches to 0, then this limiting form will be of the type 0 to the power 0. So we can observe that infinity to the power 0 indeterminate form but within power, 1 raised power infinity, again indeterminate form with power, and 0 to the power 0. So this is again indeterminate form with powers. So that's why these are called power indeterminate forms. Have a common procedure. तीनों ही power indeterminate forms का एक common procedure है. First of all, we convert these power indeterminate forms into the indeterminate form of the type 0 into infinity, and then from there we convert 0 into infinity into 0 by 0 form or infinity by infinity form. और जब हम infinity by infinity form या 0 by 0 form में इसे लाएंगे तब हम लॉपिटर रूल अप्लाई करके लिमिटिंग वैल्यू निकाल सकते हैं. Now I guess the flow diagram will help a great deal. If we are computing limit x approaches to a fx raised to power gx such that it is a power indeterminate form of the type infinity to the power 0, 1 raised power infinity या 0 raised power 0, then infinity to the power 0, 1 raised power infinity और 0 to the power 0 को तीनों ही फॉर्म्स को हम पहले 0 into infinity टाइप में कन्वर्ट करते हैं and then from there we convert this in the form of 0 by 0 और infinity by infinity whichever is convenient, एंड देन वहाँ से फिर लॉपिटल रूल अप्लाई करके लिमिटिंग वैल्यू निकालते हैं. यहाँ से यहाँ लाने के लिए we have two different procedures. In the first case we take log on both sides and second case में we take e as the base. Obviously the both of the procedures end up with the same result. So case first में if we have to compute limit x approaches to fx to the power gx, so we assume if y is the limiting value of this thing, so we write let y is equal to limit x approaches to a fx to the power gx, and then we take log on both sides. So we write then log of y is equal to log of limit x approaches to a fx to the power gx, and we know log of limit of a function is equal to limit of log of that function because log is continuous function. So it will be limit x approaches to a log of fx to the power gx, so which can be again written as limit x approaches to a, since we know log of a to the power b is b log a, so this will be gx into log of fx, and thus this is reduced to 0 into infinity type. अब 0 into infinity टाइप से 0 by 0 और infinity by infinity टाइप में लाने के लिए we write this as limit x approaches to a log of fx divided by 1 over g of x, as we also know how to convert 0 into infinity form into 0 by 0 form or infinity by infinity form. और हम ऐसा भी लिख सकते हैं limit x approaches to a gx divided by 1 over log of f of x. So that means कि limit x approaches to a fx raised power gx. So first of all log apply करके हमने 0 into infinity type में लाया, फिर then वहाँ से 0 by 0 form और infinity by infinity form में ला के हम इस पे L'Hopital's rule apply कर सकते हैं. Now in the second case we take e as the base and we know e raised power log of x raised to power m is equal to x raised to power m, since the exponential function e and log are inverses of each other. So x raised power m की image log of x raised power m और वापस exponential function फिर से x raised power m से match होगा. So that means e raised power log of x raised power m is equal to x raised to power m. So this limit can be written as limit x approaches to a fx to the power gx. So we can write this as e raised to power. अब मान लीजिए कि ये term हमारे पास x raised power m की shape में हो, then we can write this as e raised to power log of fx raised power gx with limit x approaches to a. Then we can write this as limit x approaches to a, फिर से gx आगे multiply होगा, so it will be e raised power gx into log of fx. Again, since the exponential function is continuous throughout its domain, so that means कि ये limit power में चला जाएगा. So it will be e raised power limit x approaches to a gx into log of fx. So that means it will be e raised power limit x approaches to a gx into log of fx. So this thing is reduced to 0 into infinity type, as we can already see here gx into log of fx. So this is reduced to 0 into infinity type. That means we can continue in the similar manner. So we can write e raised power limit x approaches to a. So it will be log of fx divided by 1 by g of x, or we can alternatively write this as e raised to power limit x approaches to a gx divided by 1 over log of fx. So फिर से रिवाइज करते हैं. अगर हमें लिमिटिंग वैल्यू निकालना हो पावर इंडिटर्मिनेट फॉर्म ऑफ द टाइप इन्फिनिटी टू द पावर 0 या 1 रेज पावर इन्फिनिटी या 0 रेज पावर 0, देन वी फर्स्ट ऑफ ऑल कन्वर्ट दिस इनटू 0 by 0 फॉर्म. और 0 by 0 फॉर्म में लाने के लिए वी कैन टेक log or we can take e as the base. Obviously log here means the natural log with base e. So फिर 0 into infinity form को 0 by 0 form या infinity by infinity form में लाके वहाँ से फिर L'Hopital rule apply करके limiting value निकालते हैं. Now we will be going through each power indeterminate form one by one, and first we will go through with 1 raised to power infinity. And the first striking thing about 1 raised power infinity is that कि क्या वाकई 1 raised power infinity एक indeterminate form है या नहीं, because we know x raised to power m means x is multiplied with x m times. So x raised power m means x into x into x. So it is m times x, m times x. So this is m times. So thus we can say that 1 raised to power infinity means 1 into 1 into 1 infinite number of times, which means this will be still equal to 1. Now is it so 1 raised power infinity is 1? And if 1 raised power infinity is 1, that means it is not an indeterminate form. But it is not so. 1 raised power infinity is not equal to 1. Because precisely we are dealing with the limiting forms here, and we are computing the limiting form of the type limit x approaches to fx raised to power gx, wherein अगर x a को approach कर रहा है, then f of x approaches to 1. Now since f of x is approaching 1, so f of x may approach 1 from the right or it may approach 1 from the left as well. That means कि अगर हम 1 की जगह 1.01 ऐसा कोई वैल्यू लें, since gx is approaching to infinity, so it means 1.01 raised power infinity. For our convenience, if we take 1.5 raised power infinity, then 1.5 raised power infinity, so it will approach to infinity. That means कि अगर f of x approach कर रहा है 1 को from the right, that means limiting value infinity को जाएगा. And if f of x approaches to 1 from the left, say if we are taking any value like 0.5, and we know 0.5 raised power infinity ये approach करेगा 0 को. That means कि अगर लेफ्ट हैंड अप्रोच से जाए, सो दैट मीन्स इट अप्रोचेस टू 0, और अगर राइट हैंड अप्रोच से जाए देन इट अप्रोचेस टू इन्फिनिटी. दैट मीन्स यूनिक वैल्यू नहीं आया 0 और इन्फिनिटी, सो दैट्स व्हाई दिस इज इनडिटर्मिनेट फॉर्म. एंड अगेन नॉट टू गेट कंफ्यूज्ड हियर विद द लिमिटिंग वैल्यू के एक पॉइंट पे अगर हम लिमिट निकाल रहे हैं, इन दैट केस वी से द लेफ्ट हैंड लिमिट has to be equal to the right hand limit. But here यहाँ हम a की बात नहीं कर रहे, यहाँ हम f of x और g of x की बात कर रहे हैं. So f of x और g of x पे अगर conditions apply करके f of x की condition और g of x की condition combinedly अगर हमें एक ही limiting value दे, then in that case we say कि ये पावर indeterminate form एक determinate form है या indeterminate form. But here it turns out to be an indeterminate form. So अब 1 raised power infinity को लेके कुछ example solve करते हैं. And first example is limit x tends to 0 1 plus x raised power x, and we know this is a special limit. So limit x approaches to 0 1 plus x raised power x, इसका limiting value e है. Obviously limits L3 में हमने ये limit पहले देखा था, so इसका limiting value e है. So we will prove this limit. So first we will check when x approaches to 0, so this will be 1 plus 0 1 by x. Since x is approaching to 0, so this will be 1 by 0, which will be infinity. So this is indeterminate form of the type 1 raised power infinity, which means कि 1 raised power infinity type को solve करने के लिए we'll be taking log on both sides, और हम दूसरा approach taking e as the base b apply कर सकते हैं. Let y is the limiting value, so we can write let y is equal to limit x approaches to 0 1 plus x raised power 1 by x. Next we can write taking log both sides, so it will be log of y is equal to log of limit x approaches to 0 1 plus x raised to power 1 by x. So we know log of limit of a function is limit of log of that function, because log is continuous function. So it will be limit x approaches to 0 log of 1 plus x raised power 1 over x. And next we can write this as limit x approaches to 0. We know log of a raised to power b. Log of a raised to power b is equal to b log a, b log a. So that means we can write this as 1 by x into log of 1 plus x, or we can at the same time write this as limit x approaches to 0 log of 1 plus x divided by x. Now 1 raised power infinity को convert करने के लिए first of all we take log, then वहाँ से 0 into infinity type में convert हो गई, because 1 by x means infinity and log 1 is 0, so this is in fact infinity into 0, and then we can convert it into 0 by 0 form, because log अगर हम इस expression को ऐसे लिखें then this reduces to 0 by 0 form. अब यहाँ पे हम 0/0 फॉर्म या तो l'Hopital's रूल अप्लाई कर सकते हैं, बट वी नो log of 1 plus x divided by x, this is equal to 1. Special limit, so this limit is equal to 1. And if we wish to use the limiting value, then we can check the indeterminate form. X approaches to 0, so this will be log of 1. Log of 1 is 0. X approaches to 0, so this is 0/0 form. That means L'Hopital rule is applicable. अब L'Hopital rule apply करके it will be limit x approaches to 0, differentiation of the numerator divided by the derivative of the denominator. So log of 1 plus x ही differentiation 1 upon 1 plus x divided by x ही differentiation 1. So now we can use the limiting value. So when x approaches to 0, so it will be 1 upon 1. So it will be 1. So thus this means log of y is equal to 1. So log of y is equal to 1. हमें y का वैल्यू निकालना है, न कि log of y का वैल्यू. That means we can take e as base. So we can write taking e as base. So it will be e raised power log of y is equal to e raised power 1. And we know e raised power log of x is equal to x. So that means e raised power log of y will be y. So this will be y is equal to e raised power 1, or y is equal to e. Now we can also solve this by taking e as the base. So if we write limit x approaches to 0, 1 plus x raised power 1 by x. Since we know e raised power log of x raised to power m is equal to x raised to power m, since this e and log are inverses of each other, so they form the identity map. So that means e raised power log of x raised power m is x raised power m. So we can write here limit x approaches to 0. So 1 plus x raised power m को हम ऐसे लिखते हैं, x raised power m and then e raised power log of x. So we can here write this as e raised to power log of अब x raised power m की जगह 1 plus x raised power 1 by x. So it will be 1 plus x raised to power 1 by x. So it will be limit x approaches to 0, or 1 by x multiply. So it will be e to the power 1 by x log of 1 plus x. So which will be limit x approaches to 0, e raised to power log of 1 plus x divided by x. Now since e is the exponential function and as such it will be continuous function, so therefore we have limit x approaches to 0, e to the power log of 1 plus x divided by x as, so we can write this as e raised to power limit x approaches to 0 log of 1 plus x divided by x. ये limit power में चला जाएगा because this is a continuous function. So it will be e raised power and this whole thing equals 1, जैसा कि previously इस चीज में हमने देखा. So it will be e raised power 1. So यहाँ पे भी e raised power 1. So obviously the both procedures end up with the same result. So next example is limit x tends to 0 cos of x raised power 1 by x. When x approaches to 0, so cos 0 is 1 and 1 by 0 is infinity. So this is 1 raised power infinity type. अब 1 raised power infinity से 0 into infinity type में लाने के लिए first of all we will be taking log, and then we can from there we can convert it into 0/0 form and then apply the L'Hopital rule. So we write let y is equal to, let y is the limiting value of this thing, so let y is equal to limit x approaches to 0 cos of x raised to power 1 by x. So taking log both sides, so it will be log of y is equal to, so we'll be skipping one step, so we can write it as limit x approaches to 0 because we know log of limit of a function equals limit of log of that function. So it will be limit of log of cos of x raised to power 1 by x. And then we know this can be written as limit x approaches to 0 log of cos of x raised power 1 by x. So 1 by x आगे multiply because log of a to the power b is b log a. So it will be 1 by x log of cos of x. Now from here this is reduced to infinity into 0 type because we know when x approaches to 0, 1 by 0 is infinity and log of cos 0 is 1 and this will be log of 1 is 0. So this will be infinity into 0 type, and we can alternatively write this as limit x approaches to 0 log of cos of x divided by x. Now this is reduced to 0 by 0 form because log 1 will be 0 and here it will be 0 as well. So that means we can apply L'Hopital rule, and L'Hopital rule में हम differentiation of the numerator and differentiation of the denominator. So log of cos x की differentiation, so it will be 1 upon cos of x, फिर cos of x की internal differentiation, that will be minus sin of x divided by this x की differentiation 1. So this is limit x approaches to 0, so this is minus tan of x, so this will be minus tan of 0, so this will be 0. So that means log of y is equal to 0, and again we can take e as the base, so it will be e raised power log of y is equal to e raised power 0, and e raised power 0 is 1, and e raised power log of y is y, so it will be y is equal to 1. Now दूसरे अप्रोच से भी अगर जाए, then we will write limit x approaches to 0 cos of x raised to power 1 by x. So again we will be writing this as limit x approaches to 0. So x raised to power m को हम ऐसे लिखेंगे e raised to power log of x raised to power m. So x raised to power m as e raised to power log of x ऐसे, और फिर x raised power m. So as such we can write this as e raised to power log of cos of x raised to power 1 by x, and then this will be limit x approaches to 0 e raised to power 1 by x, फिर से आगे multiply 1 by x log of cos of x, and this will be again limit x approaches to 0 e raised to power log of cos of x divided by x. और ये चीज़ हमने पहले ही इन स्टेप्स में की हुई है. दैट मीन्स कि इस अप्रोच और इस अप्रोच में क्या डिफरेंस है. यहाँ हम पहले लॉग लेते हैं फिर एक्सपोनेंशिएट करते हैं, लेकिन इस वाले प्रोसीजर में हम दोनों ही एक्सपोनेंशिएट और लॉग साथ ही लेते हैं. Now again next example is limit x tends to 0 cos of x raised power cot square x, and this is 1 raised power infinity type, and we'll be again writing if y is a limiting value, if y is equal to limit x approaches to 0 cos of x raised power cot square x, and again taking log both sides, so it will be log of y is equal to, again skipping one step, so it will be limit x approaches to 0 log of cos of x raised power cot square x. So this will be limit x approaches to 0, so this will be cot square x into log of cos x. So again we know cot square x का यहाँ multiply होगा, so because log of a raised power b is same as b log a. Now if we check cot square x when x approaches to 0, so this will be cot 0 is infinity, and log of cos x, and this will be cos 0 is 1, so log of 1 is 0. So this is infinity into 0, or we can say 0 into infinity type. That means 1 raised power infinity is converted into infinity into 0 type. अब यहाँ से 0 by 0 form में लाएंगे, so it will be limit x approaches to 0, so we can write it as log of cos of x divided by 1 over cot square x, 1 over cot square x. Now we can also write this as limit x approaches to 0. So this will be log of cos x divided by 1 over cot square x को as tan square x लिखेंगे. Now this is reduced to 0 by 0 form because so log of 0 log of 1 is 0 and tan 0 is 0. So this is reduced to 0 by 0 form, which means we will be applying now L'Hopital rule. So we'll be differentiating the numerator as well as denominator. So this will be limit x approaches to 0. So log of cos x की differentiation it will be minus tan of x divided by tan square x की differentiation. So it will be 2 tan x into sec square x. So tan से ये tan cancel होगा. अब tan से ये tan cancel होगा, which means we will be left with limit x approaches to 0 minus 1 by twice sec square x. अब हम limiting value भी use कर सकते हैं. That means when x approaches to 0, so it will be sec 0, which means sec 0 is 1, so it will be minus 1 by 2. So thus log of y is equal to minus 1 by 2. So next taking e as base, so it will be e raised power log of y is equal to e raised power minus 1 by 2, and e raised power log of y is y, so this means y is equal to e raised power minus 1 by 2, or y is equal to 1 divided by under root e. Now the last example is limit x tends to 0 a raised power x plus x raised power 1 by x. So when x approaches to 0, so it will be a raised power 0, which is 1, plus x approaches to 0, so it will be 0, 1 plus 0, and 1 by 0 is infinity, so it is 1 raised power infinity type. Now we can again write let y is the limiting value of this thing, so we can write y is equal to limit x approaches to 0 a raised power x plus x raised power 1 by x. अब 0 into infinity type में लाने के लिए, so we'll be taking up log both sides, so it will be log of y is equal to, again we know log of limit is limit of log, because log is continuous function, so it will be limit x approaches to 0 log of a raised power x plus x whole raised power 1 by x. अब फिर से लिमिट x अप्रोचेज टू 0, ये 1 by x मल्टीप्लाई होगा 1 by x इंटू log of a raised power x plus x. Now this is infinity into 0 type, infinity into 0 type, or 0 into infinity type, because when x approaches to 0, so this will be 1 divided by 0, which is infinity, and this will be log of 1, and log of 1 is 0, so this is infinity into 0 type. Now we can also write this as limit x tends to 0 log of a raised power x plus x divided by x. Now this is reduced to 0 by 0 form. That means we can now apply L'Hopital rule. So L'Hopital rule में हम differentiation करते हैं numerator की और denominator की. So it will be limit x approaches to 0. So when we differentiate the denominator, so x की differentiation obviously 1. So ऊपर अगर हम differentiation करें, so it will be 1 divided by ax plus x into a raised power x plus x की internal differentiation. So x की internal differentiation a raised power x log of a plus x की differentiation 1. And one important thing here, यहाँ पे log y, so log y is equal to this thing. We only apply L'Hopital rule on the right hand side. जो indeterminate form 0 into 0 है, उसी पे हम L'Hopital rule apply करते हैं, न कि left hand side पे, because left hand side में हम इसका limiting value calculate कर रहे हैं. So that means कि यहाँ पे L'Hopital rule apply नहीं होगा, बल्कि that will be only applied on the right hand side, which is an indeterminate form of the type 0 by 0 or infinity by infinity. Now the limiting value or we can say limits हम use कर सकते हैं. So it will be when x approaches to 0. So it will be a raised to power 0, a raised to power 0 log of a plus 1 divided by a raised to power 0 plus 0, which means log of y is equal to a raised power 0, it will be 1. So log of a, so it will be log of a plus 1. So a raised power 0 is 1, so divide में 1, which can be written as log of y is equal to log of a plus, this one can be written as log of e, because we know log of e to the base e is equal to 1. Next we can write this as log of y is equal to, so we know log of m plus log of n is log of m into n, so this will be log of a plus log of e, so this will be log of a into e. Next this log and log will cancel out, so that means y is equal to a into e. So hope to see you in the next video with the remaining indeterminate forms. So take care and stay blessed.